Hey everyone, welcome back to the Mindverse. Today we're re-diving into a question that sounds almost unbelievable at first. What actually happens when a solar storm hits the sun? We usually think of solar storms as violent outbursts coming from the sun and spreading across space. But the truth is that the sun is not just the source of these storms, it is also the place where these cosmic tempests rage in ways that are far beyond our imagination. What goes on during these massive storms? How do they form? What do they look like? And most importantly, how do they affect us here on Earth? The answers will take us deep into the heart of our star, to a place of unimaginable heat, light, and power. The sun looks calm from Earth, like a steady glowing ball that never changes. But in reality, it is an incredibly active, dynamic sphere of superheated plasma. Beneath its surface, immense magnetic forces are constantly twisting, bending, and building up pressure. Sometimes, those magnetic fields suddenly snap and realign, unleashing enormous amounts of energy. That is when solar storms are born. A solar storm can take the form of a solar flare, which is a sudden burst of radiation, or a coronal mass ejection, which is when billions of tons of plasma and magnetic field erupt out into space. These events are some of the most powerful explosions in the entire solar system. When a solar storm happens on the sun, it's like watching a titanic battle of fire and magnetism. Magnetic fields, which we can't see with our eyes, shape the glowing plasma into giant loops and arcs that rise far above the sun's surface. These loops can be so huge that entire planets like Earth could fit inside them. When the energy becomes too much, the loops snap, sending shock waves racing across the sun. In a solar flare, the energy released is equivalent to millions of nuclear bombs exploding at the same time. Temperatures in the storm region can soar to tens of millions of degrees Celsius, making the sun's already scorching surface look cool in comparison. A solar storm is not just a single event. It's a chain reaction that starts in the core of the sun, where nuclear fusion creates energy. That energy moves outward in waves, carried by boiling plasma in what's called the convection zone. Magnetic fields rise up through the surface and tangle like twisted rubber bands. When they snap, the storm explodes outward. Imagine a gigantic explosion of light, X-rays, and ultraviolet radiation bursting across space in every direction. These rays travel at the speed of light, so they can reach Earth in just 8 minutes. If a coronal mass ejection is involved, massive clouds of plasma are thrown off the sun at millions of kilometers per hour. These clouds take 1 to 3 days to reach Earth, but when they do, the effects can be stunning and sometimes dangerous. But what actually happens right on the sun during such a storm? One of the most dramatic features is called a solar prominence, where plasma held by magnetic fields forms giant glowing arcs that stretch far above the surface. During a storm, prominences can erupt, flinging plasma into space. Sometimes, these prominences collapse back onto the sun, crashing down in fiery cascades that look like cosmic waterfalls of glowing fire. Other times, they break free completely, becoming a coronal mass ejection that travels through the solar system. The sheer scale of these eruptions is staggering. A single CME can be bigger than the entire Earth, and the energy it carries can light up billions of homes for years. Scientists have even observed what look like solar tornadoes, spinning columns of plasma that are tens of thousands of kilometers tall. Imagine a tornado on Earth, then multiply its size by thousands and fill it with superheated gas moving at hundreds of thousands of kilometers per hour. That's what a solar storm can produce. These tornadoes are driven by magnetic forces twisting plasma into spirals, and they can last for hours or even days before dispersing. They are a reminder that the sun's storms are not just powerful, they are also incredibly complex. From Earth, we don't see these storms with our naked eyes, but with telescopes and satellites, scientists capture images of the sun's fury. Solar storms often appear as bright flashes or eruptions on the surface, sometimes covering areas larger than our planet. These storms are so energetic that they can actually shake the entire magnetic field of the sun, sending waves rippling outward across its atmosphere. The shock waves travel through the corona, the sun's outer layer, and can trigger more storms in other regions. It's like throwing a stone into a pond, but on a scale that makes Earth look like a grain of dust. When we ask what happens when a solar storm hits the sun, the real answer is that the sun itself changes for a brief time. The storm can rearrange magnetic fields, heat up plasma to extreme levels, and send massive amounts of energy into space. These storms can also leave scars behind in the form of sunspots, which are cooler, darker regions where magnetic fields are particularly intense. Sunspots often appear in groups, and when the magnetic fields around them get tangled, storms become more likely. By watching sunspots, scientists can predict when solar storms might erupt. The power of these storms doesn't stay confined to the sun. When the energy and plasma from a solar storm reach Earth, they interact with our magnetic field, creating dazzling auroras near the poles. These shimmering curtains of green, red, and purple light are one of the most beautiful consequences of solar storms, but the effects can also be harmful. Strong storms can disrupt satellites, interfere with GPS and radio signals, and even cause power outages by overloading electrical grids. In 1859, a massive solar storm known as the Carrington event sent electrical surges through telegraph systems, sparking fires and shocking operators. If a storm of that magnitude hit today, it could damage satellites, knock out power grids, and disrupt global communications. On the sun itself, though, storms are just a part of its natural cycle. The sun goes through an 11-year cycle of activity, from quiet periods to times of intense storms and eruptions. Right now, scientists are watching closely as the sun approaches the peak of one of these cycles, known as the solar maximum. During this time, storms become more frequent and more powerful. For the sun, these storms are nothing unusual, they are simply how it works, how it releases the massive energy stored in its tangled magnetic fields. But for us, they are a reminder of the awesome power of the star that gives us life. The beauty of solar storms is that they are both destructive and creative. They can unleash devastation on Earth's technology, but they also create the auroras that have inspired human beings for thousands of years. They remind us that the sun is not just a passive ball of light, it is a living, breathing star with a heartbeat of magnetic storms that pulse across space. Every time we see an aurora or hear about a solar flare, we are witnessing the effects of storms that begin deep inside the sun, storms that could swallow entire worlds in their fury. So what happens when a solar storm hits the sun? The short answer is that the sun erupts in unimaginable power, twisting and snapping magnetic fields, blasting radiation across space, and sending giant clouds of plasma racing outward. On the surface, it looks like fire and lightning on a scale we can barely comprehend. For us on Earth, these storms can be both dangerous and mesmerizing, a reminder of our vulnerability, but also of the beauty of living under a star that is alive with energy. The next time you look up at the sun, remember that beneath its steady glow lies a world of chaos and storms. It is a constant battlefield of magnetic forces, a storm machine that has been raging for billions of years and will continue for billions more. And every once in a while, when one of those storms reaches us, we get a glimpse of just how powerful and mysterious our sun truly is.